So corking packaging, and we will follow a little bit a kind of similar, like a little bit on the material, on how the bark is processed, the corking, the corks production, and then applications and type of cork stoppers, and a little bit on quality control as well. So I think this is another example of a bio-based material. So it's a vegetable tissue. It's harvested from the cork oak. You can see here where the major producing countries stay. So Portugal, Spain, a little bit France, Italy, and these North Africa countries as well. So there is an enormous capacity of the bark regeneration, and there are strict rules for the bark extraction in order to keep the system sustainable. And each tree is submitted to stripping or bark extraction around 16 times during its life. And very importantly, not maybe we all know, because are Italians and French and some packaging knowledgeable persons already, but there are people that think that it is necessary to cut the tree to take the bark. And cork is very light, we know. Is impermeable to liquids and gases, is elastic and compressible. So this is why it works well as a gasket, because we need to compress and have some elastic properties. It's very good insulator, not only for liquids and gases, but also as thermal and acoustic. That's why less noble cork material can be used in construction and in decoration and other applications. It's a fire retardant, so in these applications where at home we can have decoration or flooring, ceiling, and so on. So it's and it can be reusable, and it can be recycled as well. Here we have the average composition. So half of it is suberin. Then we have linen. Linen, by the way, is the same component that when we were discussing paperboard and cellulosic fibers. So what makes the fibers bound together is also linen. And then we have others, polysaccharides, steroids, tannins, so different products. This is the molecule of suberin, a kind of structure. So it's a mixture. It coats, it's organic acids that coats the walls of the cells of the cork. So and this makes the cork resistant and impermeable to water and gases. So Suberin is also responsible for the elastic properties of the cork, allowing the bending and collapse with some recovery of the cell's walls. And here we can see under the microscope how the cells of a cork are. So this structure is given by the shape of these cells that can be pentagonal or hexagonal, depending on the direction. And so it's a characteristic alveolar structure. And so the cells are arranged in rows perpendicular to the cork trunk, and they are filled. So in these empty spaces there are some entrapped air that is not easy to escape, and this is what makes the cork so resilient and so resistant to compression, and at the same time with some recovery. So this is the reason for the elasticity and also for the low thermal conductivity, because we have the air entrapped in these cells. Okay. About the bark processing, so we can see here some pictures where the barking is being processed. So there are some cuts, and then the bark is removed by experienced people that know how to do it. And during the life of the tree, there are several, as I said, 16 barking periods in average. But the first two are not used for corks production. So the first skin, let's say, the first and the second, is not good enough and is not used for corking. So the first extraction is after 25 years. Then every 9 years is barked again, but only after the third extraction is the bark with good quality. And by that period of time, the trunk should be around 2 meters high, so 70 centimeters at 1.3 meters after the floor. Yeah. Is anything not clear? Yeah. So open, separate, and cut the bark and mark the tree. So they need absolutely to mark the tree with a code to know the year where the bark was taken. So because after 9 years nobody knows which trees have been barked. So if we go in these places, we can see numbers in the trees to assist on this barking traceability. Okay, then it starts a long process of preparing the bark for the production of stoppers, and this is a long process. So a company that is producing cork stoppers now is using raw material that was barked several times ago, maybe 2 years ago. So we have first the maturation of the planks. So we can see all the planks stayed laid on the floor for at least six months, and they need to stay there without doing nothing, to get in equilibrium with the surroundings, to release a lot of things and to maturate, as they call it. Then maybe here we can say that the industrial process starts by a thermal treatment, namely boiling. So is boiled, is cooked, to reduce the microflora, so to extract substances that are soluble in water, that would be then released into the product, and also to render the tissue more soft and more uniform. So this cooking is required, and then we allow for another period of stabilization, and where the planks, after being boiled, they get flat and they lose quite a lot of this round shape that becomes because being the bark of the tree. So they become flat, and the consistency of the cork also changes. So 1 more month, and then there is the selection according to the thickness of the cork, according to very specific parameters. They decided what goes to be used in which, and we will see even in the stoppers we have different types of stoppers according to the quality of the bark. So now, after this planks selection, the corks planks are ready for the transformation. As I said, there are different molding processes that depend on the type of the cork, and natural corks are produced just by puncturing, or as it is here, by sculpting the stopper from the plank. So there is a plank and there is a puncture, and that cuts the cork stopper as it is completely natural. Then we have further steps to improve, but this is what we call the natural cork stopper. While other cork stoppers are produced not from the whole bark, but from grains of cork that are bound together to produce a cork stopper. So they are bound together with different types of adhesives. Typically is polyurethane-based adhesives. And in any case, natural corks or other corks, we have there is the need after to ratify the dimensions in order to fit well with in the finish and in the neck of the bottle. So the dimensions must be within precise tolerances, and also they are surface treated afterwards. So then we have some finishing steps, like washing again and disinfection. We have moisture equilibration steps. Then we have a final selection and classification. And today, this selection and classification is made visually, but automatically. So there are a great development in machines that are able to evaluate the surface appearance of the cork and classify according to 1, 2, 3, 5 classes: the best, the less better, and the poor. So it's a classification. And then finally we have the surface treatment with coatings and so on. Most corks are supplied under CO2 gas for preservation and to avoid microbial growth of any contamination that can occur afterwards. In principle, the industries take care, and because there are washing and disinfection and these treatments, at the end they are okay, but then there are transportation and storage in different environments, so they must avoid microbial contamination after the process. Why? Why is this important? No, you don't know? You don't know? Why? What is the biggest problem in cork? You don't know. Why? It's not exactly mold. It's not the mold. It's what can be produced by molds or by others. No. Trichloroanisotropes, TCA, is the smell of a mold. It's not the mold, it's the smell of the mold. Okay? So industry, cork industry invests thousands, millions, whatever, GCMS in a row, you know, like 10 GCMS, measuring TCA, that's trichloroanisotropes, is a class of chemicals that can be produced or by some microbial agents. And what the problem is, not toxic, but it smells awful. And you have seen Italian guys, you should know this because you produce wine and you produce cork. And when someone in the restaurant is opening a bottle and it smells the cork, yeah? You have noticed this? This is to check if the cork had this problem, because then the wine, it would not be good. So this is highly volatile. The nose can detect in very, very low thresholds. So very, very low concentrations. That's why GCMS is required to measure very low concentration of this chemical. Okay. So this is why microbial protection against microbial contamination of corks is important in this industry. I have a work running with a company, so I go to a cork company, a cork producer, so I go there often, and they have a special premium batch, premium reference of corks, natural corks, premium. So for these products that costs thousands a bottle, they smell every cork, every single cork of each slot, they smell it before dispatching to the wine filler. Okay, this is a very premium reference of corks. Okay, so every single, so 100% analysis with the nose, because the nose is better than the GCMS. Okay, so they have special panels, sensorial panels, to test. They put each single cork in each testing cup, and then they left overnight, and then the sensorial team goes there and put the nose in every single jar to test. Yeah, it's amazing. So cork applications for wines, of course, but also, and increasing, because with this non-plastic era that we are now facing, consumers don't want plastic, so we see more and more in several kitchen articles as a food contact material. So we have lids, we have cutting boards, we have trays, we have stuff that we use in our tables. So made out of cork, maybe not natural cork, of course, but agglomerated cork. That's here we see a cork that is a natural cork. Here you see, do you know what is this? What is this cork for?
Probably this is the one with adhesive.
Yes, it is. And this is specific for champagne. Champagne. How can I say? I can say because it has a main body made out of grains glued together, but here we can see 2 discs of natural cork. So this is typically for champagne, but we will see. Now there are the several types, so natural, colmated natural, technical, champagne, agglomerated, micro-agglomerated, and bar top. So these are the several types of cork stoppers. We will see now a little bit of each other. So for the natural, here you can see very well a little bit of the bark of the tree, and then how the stopper is taken out from the bark. So as it is a punching as a single strip of cork. Can be cylindrical, can be conical. The diameter should be selected according to the finish and neck of the bottle. Should be 6 millimeters higher than the bottleneck to secure and to be sure that it holds the product inside. And so when we are going to apply the cork, we need to compress, insert, and inside the neck the cork will relax and recover. So we should not compress more than 30% of the diameter before inserting, because if we compress more than 30%, we damage the cells, and then they will not recover. Okay? Also, as we saw on the glass, we should have a length that allow headspace expansion. Remember that we saw the neck size. So the length of the cork needs to match the length of the neck of the bottle. And here there are some guides and some common sizes for different types of bottles. I did not mention before that we have the Bordeaux shape of bottle, the Burgundy, again French, two French, and Rhine bottles shape. Okay, one German. So you know what is the Rhine shape? Is this type of bottle used more for white wines, the region of Rhine, so is more. And Bordeaux and Burgundy are very common. Also, if I would shape a wine bottle, it's a Bordeaux type. And here, so we have here the length and the diameter in millimeters of the corks used for different volumes of bottles. Okay? So we have density, ranges, the humidity should be equilibrated between 5 and 9, because humidity is important for this mechanical behavior. So if we are going to apply it too dry or too wet, the behavior is not good. And we have some surface treatments like paraffin, silicone, and it's important to measure the extraction force of the corks. Typically is measured 24 hours, so one day after the application. And a lot of importance is given to the visual appearance. So natural cork are the top quality of stoppers in cork. So this visual appearance is given a lot of importance as well. So when we have natural corks that somehow are not so good with this visual appearance, they have the surface treated with cork powder to fill in the pores, and this is also a real makeup, so to make the surface more uniform, a little bit less natural in terms of appearance, in my opinion, but is still done. And this cork powder that are residues from other processes is fixed with water-based adhesive. So the corks are running in a machine with the powder and with the adhesive, and gets the surface covered. And like in the other case, we have common sizes according to the type of bottle and according to the size of the bottle, to the capacity. Now we have the technical, what they call, the industry calls the technical corks. Okay, and they consist of a body which is then produced as the little pieces that are glued together, and And we may have like this, or like this. So this is called 1 plus 1 or 2 plus 0, because on the tops, in one or both tops, it can be applied a disc made out of natural cork. So as you can understand, when we have agglomerated cork, we don't have the same inertness, the same quality in contact with a product, let's say wine or champagne or, well, what could be. Okay, but we don't have trees, we don't have bark to do only, and we don't have market. We don't have market able to pay only for natural corks that are obviously more expensive. And also we have wastes, we have residues from the production of natural. So we need to find the use of those for those wastes, for those residues. And doing agglomeration is one way of using those wastes that are small parts, small particles with after removing defects and problems and so on. So this is why these are used. We need to use the adhesive. The adhesive must be food contact, okay? But for some applications, we still want that the cork in direct contact with the product be without the adhesive, without the pieces, be a natural, continuous surface of cork. Therefore, we apply these discs. And it can be one disc on the top or at the bottom, or the two on the bottom, being the bottom, the part that is in contact with the product. Okay? So, again, some dimensions for you to know if you need to order some corks for your wine. Then we have here the champagne, and we have again the disc or the discs applied on the face in direct contact. Please note that when the stopper is unused, is like this cylindrical part, and everyone recognizes this as a champagne cork stopper, because the cork stopper gains this mushroom-like shape only after being used. Before use, it is cylindrical like that. But there is a small portion that is left outside of the bottle, and that is caged with this metallical thing, and because we have the huge internal pressure on the liquid side, so it gains this mushroom shape. Okay. So typically they have a higher diameter because the need to hold the pressure is much higher. Then we have here agglomerated, simply agglomerated, because we don't put any discs of natural cork, and this can be done by extrusion or by molding. There are two, and there are different types according to the different granulometries that are used for the small pieces of cork. Okay, we have more corks made with smaller particles or bigger particles, depending on the quality that is required. Okay. And so this is a specific type within the granulated, or we call it micro granulated, because we have also agglomeration of pieces of cork, but we mix them with microspheres and with adhesive, and these microspheres are going to be expanded during production, and this will increase a lot the good performance of the bottles, of the corks, sorry. So and there are not many companies producing these, and we have different lengths depending on the bottle that we are going to use. And finally, the last type is the bar top type of stoppers. I don't know if you recognize some kind of applications. In my country, we use this for port wine, typically for port wine, for the cheaper port wine. So the port wine that is sold already aged, that is not going to be stored longer, but also for other applications. So I don't know if you have other applications. Yeah, some liquors. Yes, indeed. Like, yeah, Shiraz from Spain, maybe. In Italy, some limoncello, maybe limoncello. Yeah, right. So I don't know. Oh, it's here. Whiskey, some whiskeys, cognac. I think in cognac is common, right? And there are very nice things, because then they put wood on the bar, so it's a bar top. It means that we have the cork portion, and then we have a other material bar, like to hold to handle the stopper. It can be plastic or wood or even steel, so these more noble appearances if it is required. Ceramic as well. And this is very important for those liquors and products that are typically not consumed at once, once the bottle is open, because with these cork types we can reclosure easily, which we cannot with the other types of closures. And also here there is some indication of common sizes. Okay. And finally, we have here some quality control that is done in a, as I said, in a quality control base. So routine, like humidity or dimensions, starting with density. Then we have stopper's performance, the compression and relaxation. So how recovery after compression. These two are connected. So if we compress for a certain period of time, if the cork is elastic and recover the full dimensions. If it absorbs wine, because we don't want it to absorb too much wine, and the extraction force depends a lot on the surface treatments, silicone or waxes, And then we have some migration into the product parameters related. We want to avoid oxidant residues from those washing steps, from disinfection steps. Typically, disinfection is done with hydrogen peroxide. It's interesting to when we visit a plant that uses this type of substance to disinfect the cork. The operators working on that area are all blonde, completely blonde, because of the atmosphere and the oxidant atmosphere. So they have this, and so but we need to avoid, of course, in the air and in the residues. So this is something that is controlled. We don't want organoleptic changes like TCA and these other problems related to cork flavor. Then we have microbial counts, so it's always controlled. And adhesives and all coatings and surface treatments must comply with the legislation for food contact materials. So there is a special group within Europe working in this field to have harmonized, not exactly legislation, but recommendations regarding these chemical substances that are used with the cork, together with the cork somehow. Okay? So, this is the very last slide I had on cork. Questions? It's about, yes?
One question, how is the compression of the cork before the closing technically done? So how does the machine look like that is doing this compression?
I can show you. I don't have in these slides. It's something like this.
And it's just pressed, then put into the bottle, left, and then is extending like that fast?
No. There is not that fast. There is a rule that, well, okay, first the machine has a certain four blade-like pieces of metal. So it's four because it's 1, 2, 3, 4 that compresses from all sides.
Okay.
So that there is no this, stretch, compress more in one dimension than in the other. So it must be symmetrically compressed, and this is done by a square shape like piece. Okay, so 4 pieces, and then there is a puncture that inserts. Okay, then it's there, then it expands immediately somehow, but not enough to keep the hermeticity. So one rule is the bottle must be standing for some time periods before being laid down, before people be allowed to lay down. That's why we have in the filling lines, we have long lines, because we need to allow for the time to pass for the cork to recover fully what is expected to be fully recoverable before being ready to be handled, like boxing and lay down. Okay? Yeah.
Sorry, you said you visited a company where they do the sensory analysis of the cork one by one. There are not some instrument like electronic nose
They have also, and electronical nose and GCMS-based analysis are used for regular corks. So they sample and they do the analysis, but that is done in a sampler, in a sample, not in the whole full number of corks that that compose the batch. This is, please understand, this is a very premium, very premium reference. So they don't do this in each case, okay?
So it's high quality.
Is the toppest quality. Is for those bottles that one bottle costs 1,000 euros, not 5 euros, not 1,000 euros. So there are such cases, okay? So they buy like one lot can be 100 corks or 1,000 corks, not for millions. Okay? So for this very premium reference of products, they have this commitment to put the nose in every single units of the lot. And this is because they have trained persons, they have trained noses that work better than the automatic equipments. Yeah, okay.